Okay, so let's imagine this. You're online, right? You type in a website address, maybe geeksforgeeks.org, hit enter.
And bang, the page just pops up almost instantly.
Exactly. Feels totally simple. But what's actually going on there in that split second? All that invisible stuff making the connection.
Yeah, it's one of those things, isn't it? So critical, but totally hidden for most users. It's like the plumbing of the internet.
Totally. And that's exactly what we're diving into today. We're going to unpack the domain name system, DNS.
Right, the internet's phone book,
It's
basically.
like a super smart GPS for the internet, guiding your request exactly where it needs to go.
That's a good way to put it, yeah.
Yeah.
Because the internet is huge, constantly changing.
For this deep dive, we're leaning on some really great info from Geeks for Geeks. They break down how this whole system works.
Mm-hmm.
And our mission, really, is to demystify DNS for you. Show how those website names we all know.
Like google.com or whatever.
Yeah, how they get translated into the numbers computers actually use to talk to each other.
And why that matters, for just browsing the web day to day.
Absolutely. So let's start with the problem DNS actually solves.
Okay, well, think about remembering IP addresses. Those strings of numbers like 142.250.190.14 for Google, for instance.
Right. Imagine trying to remember that for every site you visit. Forget it.
Exactly. It'd be impossible. We're just, better with names. Words.
So that's the core job of DNS then, translating the easy name, www.google.com.
Into the computer-friendly IP address, that 142 number.
And that translation is what lets my computer find the Google server out there somewhere.
Precisely.
Yeah.
It enables the connection. Without DNS doing that constantly, seamlessly in the background, well, the internet just wouldn't work like we expect it to.
Okay. So how does it do that translation? It can't just be like one giant list somewhere, can it? That sounds fragile.
No, definitely not. It's much smarter. It's set up as a hierarchical system, and it's distributed. Think of it like a huge branching tree.
A tree structure.
Yeah. So when your computer needs an IP address, the request kind of goes on a journey through different levels of this tree.
All right, so where's the first stop on this journey?
Often, it's really close by. Your own computer's local cache.
Cache. You mean like temporary memory?
Exactly.
Okay.
Your browser, your operating system, maybe even your router, they might have stored the IP address from the last time you visited that site.
Ah, okay. Like a little cheat sheet. That would speed things up, wouldn't it?
Definitely. Caching is huge for performance. But if the answer isn't in that local cache,
Then what?
then the request goes to something called a DNS resolver, or sometimes called a DNS client.
And that's usually run by my internet provider.
Typically, yeah. Your ISP provides one automatically. Think of the resolver as the main coordinator for the search.
Okay, coordinator. And what does it do first? Does it check anything else locally? The source mentioned host files?
Good point, yes. It might check the hosts file on your computer first.
Yeah.
That's just a simple text file where you can manually map names to IPs.
Okay, but that's probably not common for everyday browsing.
Not usually, no. More for specific network setups. So, assuming it's not in the cache or the host file, the resolver kicks off the real DNS lookup process.
Yeah.
It reaches out onto the internet.
Right, and this is where that hierarchy comes in, the different server levels.
Exactly. First, the resolver asks one of the root DNS servers.
Root servers, okay. Do they have all the answers?
Nope. They don't know the specific IP for, say, geeksforgeeks.org. But crucially, they do know which servers manage all the .org domains, or the .com domains, or .uk, whatever it might be.
Ah, I see. So the root server is like a main directory that points you to the right section.
Precisely. It directs the resolver to the correct top-level domain, or TLD server.
So for geeksforgeeks.org, the root server says, go ask the .org TLD server.
That's the idea.
Hmm.
And the .org TLD server, well, it knows about all the domains ending in .org. It knows which specific server is the authority for geeksforgeeks.org.
The authoritative server.
Yep. The authoritative name server. That's the one that holds the actual definitive record, the IP address for that specific domain.
So TLD points to authoritative,
And the authoritative server sends the IP address back to your resolver.
which then sends it back to my computer.
Right.
And then my browser uses that IP address to finally connect to the Geeks for Geeks web server and get the page.
That's the whole chain.
Wow. Okay, that's actually quite a few steps. Feels instant, but there's a lot happening.
It's incredibly fast, usually milliseconds. But yeah, it's sophisticated dams. And it relies on some key bits and pieces, concepts the source mentions. DNS records, the namespace, name servers.
Okay, let's break those down. DNS records first. What are they exactly?
Think of them as the actual entries in the DNS database, little bits of information. The most common one, the A record, just links the domain name to its IP address, the IPv4 address specifically.
And they contain other info too.
Yeah, like how long that information is considered valid for caching. That's the TTL, or time to live. Keeps the information fresh. And these records are stored in that tree structure we talked about.
Got it. And the namespace sounds a bit abstract.
It kind of is. The namespace is just, well, it's the entire set of all possible domain names, everything under the DNS umbrella.
Okay.
And DNS uses a hierarchical namespace, which allows for that structured system, root, TLD, subdomains, and so on. Its main job is just maintaining that link, that binding, between a name and its value, like the IP address.
So the namespace is the structure, and the name server is what uses that structure.
You got it. The name server is the actual software and hardware doing the work, answering the queries, navigating the hierarchy. Our source also mentions zones and domains. A zone is more like an administrative chunk of the DNS, while a domain is the specific branch, like geeksforgeeks.org, within that structure. Often one zone manages multiple domains.
Right. Okay. Now, Geeks for Geeks also talked about different types of domains. Generic, country, inverse. What's the deal there?
Yeah, so generic domains are the common ones we see all the time, like .com, originally for commercial sites.
But now used for everything.
Pretty much. Then you have .edu for education, .org for nonprofits, .net, which was for networks but is also broader now, .mil for military. They give a hint about the site's purpose sometimes.
Makes sense. And country domains. Those seem obvious.
Yeah, totally straightforward. Just indicates the country, .in for India, .us for the United States, .uk for the UK, and so on. Each country has its own authority managing its TLD.
Okay. But then inverse domain. That sounds backwards.
It kind of is. Normally, DNS goes name to IP. Inverse DNS lets you go IP back to name.
Oh, okay. Why would you need that?
Sometimes useful for logging, or troubleshooting, or verifying where a connection is coming from. There are special zones and record types for it, and tools like nslookup, which the source mentions.
nslookup.
Yeah, it's a command line tool. You can type nslookup and then the IP address for, say, Geeks for Geeks, and it should tell you the domain name associated with it. It does that reverse lookup.
Huh. Interesting. Okay, so we've covered the structure, the components, the domain types. Let's circle back to the lookup process itself, that coordinated dance between the servers.
Right, the DNS lookup or resolution. And just to stress it again, this whole thing is what lets us use easy names instead of those clunky IP numbers.
Yeah, can't emphasize that enough. And the key players are the resolver, the root server, the TLD server, and finally the authoritative server, each passing the request along.
Exactly. Resolver asks, root points to TLD, TLD points to authoritative, authoritative gives the answer. It's a chain of delegation.
Now, the article mentioned different query types too. Recursive, iterative, non-recursive. How do they differ?
Okay, so these describe how the resolver talks to the other servers. A recursive query is basically the resolver saying to another DNS server, find this IP address for me and don't come back until you have it or tell me you absolutely can't find it. The server has to do the full work or return an error.
So it's demanding the full answer.
Pretty much. Now, an iterative query is different. The resolver asks a server, and that server gives the best answer it has. If it doesn't know the final IP, it might say, I don't know, but this server might know more. It gives a referral.
Ah, so it's more like getting directions step by step. Try asking over there.
Exactly. The resolver has to do the legwork of asking the next server in line. Most communication between DNS servers themselves is iterative.
Okay. And non-recursive.
That's the simplest. It's when the resolver asks a server that already knows the answer because it's in its cache.
Caching again. So if the server has the answer cached.
It just gives it back directly. No need to ask anyone else. Quick and easy.
Which brings us nicely back to DNS caching. You said it's crucial for speed.
Absolutely crucial. DNS caching is just that process. DNS resolvers, even your own computer or router, temporarily store the answers, the domain names and IP addresses they've looked up recently.
For that time to live period you mentioned?
Exactly, for the duration specified by the TTL and the DNS record. And the benefits for you, the user, are huge.
Like faster loading times.
Definitely. First, speed. Sites you visit often load way quicker because the IP address comes straight from the cache. No need to go through the whole multi-server lookup again.
Makes sense why my regular haunts pop right up.
For sure. Second, it reduces internet traffic overall. Fewer queries bouncing around between root servers, TLDs, authoritative servers. It eases the load on the whole system.
Less congestion.
Right. And ultimately, both those things just make for a better user experience. Smoother, faster browsing, less waiting, more doing.
So let's sort of wrap this up. DNS is this vital but usually invisible engine under the hood of the internet
Totally. It takes the names we use, the website addresses.
and translates them into the numerical IP addresses that computers need to actually find each other and communicate online.
And it does this using that clever hierarchical system. Root servers, TLD servers, authoritative servers, all working together.
Solving that massive problem of us not having to memorize billions of numbers.
Thank goodness for that. It lets us use names we can actually remember.
And thanks to things like caching, it all happens incredibly quickly, making the web feel seamless.
Which kind of makes you pause and think, doesn't it?
Yeah.
How much our entire digital world relies on this translation service.
Yeah, it seems simple on the surface, but it's fundamental.
Absolutely.
Mm.
So maybe a final thought for you listening. What would happen if this internet phone book just vanished one day? Or even just got really slow?
Whoa, that's kind of scary to think
It
about.
makes you wonder, what other invisible infrastructure is humming away, making our digital lives possible? Makes you look at clicking a link a little differently, maybe.